Hello and good evening everyone. Today me and my team members like to present about math differentiation. After that, I like to talk about the introduction. Differentiation is a mathematical process that involves finding the rate at which a quantity changes with respect to another. In calculus, it refers to finding the derivative of a function which gives the rate of change of the function at any point. It's crucial in analyzing functions, optimizing problems, and understanding the behavior of functions. After that, I like to introduce my team members Morgan Sundaram, Dini Asif bin Norazizan, Muhammad Asla bin Shaharuddin. And lastly, my name is Ashbin. After that, example of application. This is the application of in real life. Differentiation, a fundamental concept in calculus, find numerous application in near real life scenarios across various fields. It enabled us to analyze and optimize a wide range of processes, providing valuable insights and solutions. Here we explore some key application of differentiation in real life. In physics and engineering, differentiation helps us to understand motion and change. By differentiating displacement with respect to time, we obtain velocity and acceleration. This knowledge is crucial in designing vehicles, predicting the behavior of objects in motion, developing control system of robotics. In economics, differentiation assists in maximizing profit and minimizing costs. By differentiating cost and revenue functions, we can determine the production level that maximize profit. Additionally, the concept of marginal analysis, which involves calculating the rate of change of cost or revenue, help in optimizing decision-making processes.
The graph of a curve with equation y equal 2x cubed minus 3x squared. Use differentiation to find expression for dy over dx. Y equal 2x cubed minus 3x squared. Dy over dx equal 6x squared minus 6x. Find the coordinate of any stationary point on the curve at stationary point dy over dx equals 0. 6x squared minus 6x equals 0. 6x in bracket x minus 1 equals 0. 6x equals 0, x equals 0. X minus 1 equals 0, x equals 1. 1x equals 0, y equal 2 in bracket 0 minus 3 in bracket 0, y equal 0. When x equal 1, y equal 2 in bracket 1 cube minus 3 in bracket 1 square, y equal minus 1. The stationary point are 0, 0 and 1 minus 1. How many stationary points does the graph have? 2. Determine the x-intercept and y-intercept point. The x-intercept point is an xy with y equals 0. When y equals 0, 2x cubed minus 3x squared equals 0. X squared in bracket 2x minus 3 equals 0. X equals 0. 2x minus 3 equals 0. X equal 3 over 2. X equal 1.5. The x-intercept point are 0, 0 and 1.50. The y-intercept point is on xy with x equals 0. When x 0, y equal 2 in bracket 0 cube minus 3 in bracket 0 square. Y equal 0. The y-intercept point is 0, 0. Determine the nature of any stationary point you found in part 2. Justify. The nature of any stationary point d square y dx square equal 20x minus 6. When x 0, d square y dx square equal 20 in bracket 0, 6 minus 6 d square y over dx square equal minus 6 smaller than 0. The point 0, 0 is maximum point. When x 1, d square y over dx square equal 20 in bracket 1 minus 6 d square y over dx square equal 6 bigger than 0. The point 1 minus 1 is maximum point. This is graph question A.
Question 3. Two coordinates. Question 4. X-intercept x cubed plus 6x squared minus 5 equal to 0. In bracket x minus 0.85 in bracket x plus 5.85 and in bracket x plus 1 equal to 0. And we will get x equal to 0.85, x equal to negative 5.85 and x equal to negative 1. Question 5. d square y over dx square equal to 3x square plus 12x equal to 6x plus 12 in bracket x minus 0 in bracket x plus 4 equal to 0, x equal to 0 and x equal to negative 4. 6 in bracket 0 plus 12 equal to 12 and 6 in bracket negative 4 plus 12 equal to negative 60. H. Y equal to x cubed plus 6x squared minus 5. Question 1. dy over dx equal to 3x squared plus 12x. Question 2. dy over dx 0. 3x squared plus 12x equal to 0. In bracket x minus 0 and in bracket x plus 4 equal to 0, and we will get x equal to 0 and x equal to negative 4. Y equal to 0 cube plus 6 in bracket square minus 5 and equal to negative 5, and the coordinate is x 0, y negative 5, and 2 y equal to in bracket negative 4 cube plus 6 in bracket negative 4 square minus 5 equal to 27, and the coordinate is x negative 4 and y 27. And this is a graph for question 6.
Finally, it's a summary. Certainly, differentiation is a fundamental concept in the calculus that involves finding the rate at which quantity changes. It's a process of determining the derivative of a function, which gives the slope of the function is a graph at any point. This slope indicates how the function is changing at that particular points. And differentiation has numerous applications across various fields, including basic economics, engineering, and more, where it's used to analyze the rate of the change, optimizing, and understanding the behavior of a function. That's all. Thank you.